In the previous lecture, we have seen about the correlation coefficient, the all Pearson's coefficient of correlation, and now we have to see the Spearman's rank correlation coefficient. Okay, so what is the difference between the Carl Pearson coefficient of correlation? That gives you the decision how to have the decision, and the next is rank correlation coefficient. So that gives you the idea whether the decision taken by the judges or by the authorities is correct or not, and if it is correct, up to what extent it is going to be correct. Okay, so let us try to have the rank correlation coefficient. So now today we have to see the rank correlation coefficient. This is denoted by capital R. Okay. So the thing that we need to understand is Spearman's rank correlation coefficient. Okay. So here this is denoted by capital R. So we have the formula for this capital R as R is equal to 1 minus 6 times summation di square upon nq minus n. Okay, so what we have here, so we have where this di is nothing but the difference between the ranks, and n is the number of observations. Okay, so I want you to write this formula and this Spearman's rank correlation coefficient. Okay, so we can go for the example. Okay, so please write down this. We have to study now Spearman's rank correlation coefficient, and the formula for this capital R is going to be R is equal to 1 minus 6 times summation di square nq minus n, where this di is equal to the difference between the ranks, and n is the total number of observations. Okay. So here, one thing you need to note. Okay. So one thing that you need to understand. Okay. So here, the value of this R. Okay. The value of Spearman's rank correlation coefficient coefficient is between -1 and 1. So that is what we have, -1 less than or equal to less than or equal to 1. Okay, so the value of this R is again between -1 to 1. Okay, so that we need to remember. The value of this capital R also cannot be less than -1 and cannot be more than 1. Okay. Now here we need to understand the ranks. Okay. So how we are able to assign the ranks. Okay. So if you remember, while we consider the first student, second student, or first rank, second rank in our class, what we consider is we consider more marks, better rank. Okay, so this is a simple thing that we need to understand. More marks, better rank. Okay, so this is one of the thing. Okay, or if you see the game of the tennis, for example. Okay, so in that, what you have less mistakes, better rank. Okay, so there are two types of rank to decide. Okay, so one type is more marks, better rank, and then the other is less mistakes, better rank. Okay, so the question is more marks and less mistakes, so we are easily able to understand. But what is mean by better rank? Okay, so better rank means 1, 2, 3, 4. Okay, so better rank means the ranks will be assigned in the ascending order, whereas we consider the more marks. That means marks we have to consider in descending order, and then a rank we have to consider in ascending order. So this is called more mark, better rank. Okay, the either way, less mistakes, better rank. Okay, so what do you mean by less mistakes, better rank? So the least number of mistake will get a better rank. Better rank means 1. So in this case, the number of mistakes is also increasing. That means ascending, and the rank is also ascending. Okay, so any one of these two you have to consider. Okay, so either you consider more mark, better rank, or you consider least mistakes, better rank. Okay, so that's how we have to give the ranks. Okay, so once how do we give the rank, that is clear, then we are easily able to solve the problem. So now tell me, have you got the idea how to give the rank? You understood how to give the rank? You understood the statements that more marks, better rank, and less mistakes, better rank. So the difference between these two statements, okay. So that's good. Okay, because once you can understand how to give the ranks, then only we are able to solve the problem. Okay, because we have to assign the ranks here, and that's why we have to be careful. Okay, so let us try an example based on this. So what we have to do, or what are the steps to be followed, that we'll see now. Okay, so here we have. So these are the steps that we need to consider. Yeah. So see here, what we have to do is we have given the X data and Y data. Okay. Now what we have to do is we have to write first the Spearman's rank correlation coefficient formula. Okay. So that's what we have seen here. Okay. So this is the formula that we have to write. Okay. And then once you write this formula, then prepare the table. The X and Y columns are given to us. So we have to write R1. R1 is the rank of X. Okay. And R2. R2 is the rank of Y. Okay. So, and then we have to consider the difference between these two ranks. So R1 minus R2. And once you know this difference, then we have to square that difference. Okay. So square this difference, and then we are interested in square of the difference. So you can see the formula. So we want only square of these differences. Okay, and n is known to us. Okay, so n is the number of um, observations. So how to give the ranks? So ranks we have to give in an increasing order. So as I said, we have more marks, better rank. Okay, so that is the first principle that I'm going to use. More marks, better rank. Okay, and then we have to give rank to find the difference, square the difference, and then find the sum of this difference only. Use these values in the formula of Spearman's rank correlation coefficient, and once you are done, you will get a value. Okay, so this will be the columns in our table, and this is what we have to calculate. Okay, so once we get this value, we are ready to calculate the Spearman's rank correlation coefficient. So what we have to understand is the rank. Okay, so when there is a word rank, we have to find the capital R. When there is no word rank, we have to find the small r. Okay, so if you remember these names, that's good. If you do not remember who is the Carl Pearson and then the other is Spearman's. Okay, so forget about the Carl Pearson and Spearman. Remember small r and capital R. Capital R is for rank. Okay, and then if there is no rank, then it is going to be small. Okay, so that's what we have. Let us try an example. Okay, so we consider the example. Okay, so let's have an example. So here it is given that from the following data, calculate Spearman's rank correlation coefficient. Okay, so as I said, we have to be careful for this word called rank. Okay, and once there is a rank, that means this is going to be a capital R. Okay, so we have to calculate the capital R now. Okay, and now let us see. So we go with the solution. Okay, so what we have here, let capital R be the Spearman's rank correlation coefficient between X and Y. Okay, so this X data and Y data is given. So what we have, so we have this R is given by the formula 1 minus 6 times summation di square upon n cube minus n. So let this equation 1. Okay, then what is di is here? So where di is equal to what will be having difference between the ranks. Okay, and what is n? N is number of observations. Okay, so n is going to be number of observations. So what is the value of n here? So here n is equal to, see how many observations are given to you. So we have this is 9 observations are given to you. So the value of n is going to be 9. Okay, so here the value of n is 9. Okay, and now we consider the table. Okay, so when we consider the table, what are the columns in the table? X, Y, R1, R2, D, and D square. Okay, so these are the columns that we have to consider here. Okay, so let us consider the table. Okay, so we are able to make the table. See here. So make this table. You'll be having X, Y, then you'll be having R1, R2. Okay, then we have here Pi is equal to R1 minus R2, and we want Di square. So we are interested in this Pi square. So this is the term of our interest. Okay. So let's have this table. So I hope you are calculating this table with me. So we are interested only calculating the last column. Okay. So write down what are the observations we have. So we have this 39, 59, 23. Okay. We have 39. Now you can have this 59, 23. 59, 23. What about the Y column? So 53, 38, 73. 53, 38, 73. Okay. Then what we have X 45, 36, 47. So 45, 36, 47. Okay. What about Y 61, 78, and 63? It is 61, 78, 63. Okay. What we have then 53, 18, and 63. Okay. So this is 53, 18, and 63. Okay. And now what we have Y 48, 83, and 41. So it is going to be 48, 83, and 41. Okay. So that's what we have. Okay. Now see. So now we have to give this rank. Okay. So what do you have here? I can say R1 is equal to rank of X and R2 is equal to rank of Y. Okay. So this is going to be rank of X and this is going to be rank of Y. And now see, as I said, maximum marks better rank. So what is the maximum value in X column? Okay, so we have to consider X column only when we are giving rank to X. So X column we have maximum is going to be this 63. So we have better rank, that means one rank. Okay, then after that we have 59. So this is 2. Then after that we have 53. So it is going to be 3. Then after 53, what do we have? 47. So this is 4. 45. So this is 5. Then we have 36. So this is going to be 6. Sorry, we have 39. So this is going to be 6. Then 36. So it is going to be 7. 23. So this is 8. And 18. This is 9. Okay, so see here how we have given the rank maximum marks better rank. So 63 is maximum and we started with the one rank, and then accordingly we have written this. So what we did here, so this is as you can see, we have considered this observations as 63, then we have considered 59, then we have considered 53, then we have considered 50. So we have 47, then we have 45, then we have 39, 36, and then we have 23 and 18. Okay. So see here, what we did is we arrange this marks in a decreasing order, and then we have considered the rank. So this is first rank, second rank, third rank, fourth rank, fifth rank, sixth, seven, eight, and nine. So this way we have assigned the ranks to this observation. Okay, so that's what we have. Now we are done with the X data. So we have to consider Y data. Okay, so if you want to consider Y data, now you can have. So maximum you can see is going to be 83. So I have this is 83, or what we can do is we can write the observations as they are. Okay, so I'll write this observation. So I'll be having 53, 38, then I'll be having 73, 61, then 78, then we have 63, then we have 48, then we have 83 and 41. Okay, so now you can see who is maximum. Maximum is 1. So we can have this 83 will get 1 rank. Then after that, what is the maximum? 78. So this is going to be 2. Then 73. So this is going to be 3. Then we have 63. So this is 4. Then 61, 5. Then we have 53, 6. Then we have 48, 7. Then we have 41, 8. And then we have 39. So this is 38. This is going to be 9. And hence we got the ranks now. So let us write. So this is going to be 1. Okay, 83 1. Then this is going to be 2. And what do you have for 3? So it is going to be 73. So it is going to be 3. Then we have next is going to be 4. This is 5. Okay. Then we have this is going to be 6. So next is going to be 7. This is 8, and this is 9. Okay. So this way we are able to get the ranks for this observation. Okay. So once you get the ranks for this observation, now the next column we have to calculate the difference between these two ranks. So here it is 0. Here it is -7. This is going to be 5. This is going to be 0. This is going to be 5. Then this is 0. This is going to be -4. Going to be 8. And that's what you'll be having 7. Okay. So once we are able to calculate the difference between these two ranks, then we have to calculate the square of these differences. So here we have 0. This is going to be 49. This is 25. This is 0. This is going to be 25. This is 0. This is 16. So here we have 64. This is going to be 49. And now give me what this value is. So calculate this values. What this value is going to be. So I hope you are able to understand the table. Okay. So you understood the table? Yeah, that's good. So what is the value of summation di square you are getting? What is the value of summation di square? Yeah. So you got a value that is going to be 228. Okay. So that's good. Okay. So you got this value to be 228. Okay. And once you get this value, okay. So we can write here from equation 1 we have. So what is the term you will be having here? See, R is equal to 1 minus 6 times 228 upon 9 cube minus 9. So here n is going to be So what we know is since summation di square is equal to 228 and n is equal to 9. So these are the only two values that we have to put to calculate. And then you got this is going to be what you got is exactly. Okay, so what is the value that you are getting for this? We have to be careful. We'll get only one value. We cannot get how the two values. Okay, so yeah, you calculated and you got it. That's good. So the value is going to be 0.9. Okay, so this is going to be 0.9. And hence we can say, okay, so we got here R is equal to minus 0.9. So we can say is the Spearman's rank correlation coefficient in X and N. So that's what you have. Okay. I hope you got this answer. You got the method. Do you have any doubt in this example? Okay. That's great. You don't have any doubt. Good. Okay. So let us have the another example. Okay. So we'll see the another example. So we have the another example here. Okay. So find from the data following data, we have to calculate the Spearman's rank correlation coefficient. Okay, so as I said, what we have to be careful about the word rank. So once you get the word rank, then that means we have to find a capital R. So we go with the solution. So what we'll be having here, let R be the Spearman's rank correlation coefficient between X and Y. Okay, so what we have here, then we have R is equal to, what is the formula for R? 1 minus 6 times summation di square on n cube minus n. So this equation 1. So where what we're having di is equal to this di difference between the ranks of x and y. And what is n? N is number of observations. Okay, so you can see how many observations are there. So here you have 8 observations. So what you can say here, so here n is equal to 8. Okay, so now we have 8 observations here. Okay, now what we have to do next? We have to consider the table. So now consider the table. So let's have the table here. Okay. So what are the terms we have to consider in the table? We want x, we want y, then the rank of X, the rank of Y, Di is equal to rank of X minus rank of Y. Okay, and then we want Di square. Okay, so that's what we have. You can see how many observations we have. We have 8 observations. So let's have this. So I hope you are making a table with me. Okay, so please make this table. We have to calculate. We have 8 observations. Okay, so now see what are the observations we have. So we start with X, 65, 67, 69, 71, 73, 75, 77, and 79. Okay, so let us write these observations. So we can have, I start with 65, 67, 69, 71, 73, 75, 77, and 79. Okay, so we have this 8 observations. Uh, Here we want summation di square. So that's what this is how we have to make the table. Okay. Then see the y observations. So what are the y observations? 55, 46, 64. So we have 55, then 46, and 64. Okay. Next we have 73, 91, and 82. 73, 91, and 82. Now, what do we have next? 93 and 97. So, 93 and 97. Okay. Moreover, what we know is R1 is equal to rank of X and R2 is equal to rank of Y. Okay. So, let's have this ranks. What you will be having for R1. So, one thing you need to remember, maximum mass better rank. So, we can have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, what about this will be having 1, 2, okay, sorry, we have, this is 2, this is 3, so we can have 4, going to be 5, 6, 7, and 8. Okay, so see here 97, 93, 91, then we have 82, 73, 64, 55, and 46. So this is how we got the ranks. Now let us find the difference. So the difference is going to be 1 year. This is -1. 0, 0, 1 minus 1 is going to be 0, 0. And then calculate what we have here. So it is 1, 1, 0, 0, 1, 1, 0, 0, and that's going to be 4. Okay. So easy calculation. That's what we got. Okay. And now we write the formula. So what we can say is from equation 1, we have R is equal to 1 minus 6 times summation di square n cube minus n. So here what we'll be having 1 minus 6 times 4, and here what will you have 8 cube minus 8. So here what I get is summation di square is equal to 4 and n is equal to 8. Okay, so this is what we have to put. Now tell me what is the value of r that you are getting. Okay, so you got so please be careful, 9533 or 2328. Okay, 952328 238, that is the correct answer. Okay, so we can have this going to be we got the answer, and that is 0.9523. So 0.23 or 24, that doesn't matter, but this is the answer you will have. Okay, so we got the answer. R is equal to 0.9523. Okay, this is the answer we accept. Okay, and then we can say is the Spearman's rank correlation coefficient. Okay, so this is going to be the Spearman's rank correlation coefficient. Okay, so that's what you have. Okay, do you have any doubt in this example? Do you have any doubt in this example? No. Okay, that's great. So we'll try some more example. Okay, but now if any observation is repeated, then what? Okay, so this example we have seen that there were no repeated values, but suppose if any observation is repeated, then what that we have to see. Okay, so let us see the case when the values are repeated. Okay. So this is going to be easy. Okay, when we don't have the repeated values, but what if we have the repeated values? Okay, so this is what we will be having. So here we have to modify this formula slightly. Okay, so what is the modification here? See the modification that these are the extra terms that we have to consider. Okay, so what we have? We have 6 times summation di square. This term is r as it is, but when we have the repeated value, we have to consider these terms. Now the question is what these terms are. Okay, so we can write here where mi is equal to ith rank repeated mi times. Okay, so what is mi here? So that means m1 is the first rank repeated m1 times, m2 equal to the second rank repeated m2 times, and so on. So this is the additional thing That we have to take care. Now, how do we get this repeated rank then? Okay. So the procedure to find this is here we consider, okay, the repeated rank, and we average this repeated ranks. Okay, so we have to consider the average in repeated rank. Okay, so this is the procedure when procedure to calculate capital R when the data has repeated values. Okay, so when the data has a repeated value, then what we have to do is we know how these are only the columns of the table, so the columns will not going to be changed. Only thing is that we have to consider the ranks, okay, properly. Okay, so how do we give the ranks now? Okay, so if we have two same observations, then how we are going to consider the rank? Okay, so here we use the idea of averaging. Okay, so suppose there are two observations. So for example, there are observation 78, 78, and here we have 79. So this will have the first rank. What about these two? This will have the second and third rank. Okay, so if I have second and third rank, then any one of this I cannot have the second rank and the other have the third rank, because if I give the third rank, then it will be a discrimination. Okay, and that's why what we do is we consider the average. So what is the average? 2 plus 3 by 2. So number of times it is repeated 2 times, and then that's why it is going to be 2.5. So the rank of this will be 2.5, and the rank of this observation will be also 2.5. And in this way, the same observations will get the same ranks, and hence there will be no discrimination with any one of the values. Okay, so this is what we have to add here. Okay, now let us see an example. Okay, so we'll have the example here. So let's have an example. So there's going to be the example 3. We have to find the Spearman's rank correlation coefficient from the following data. So in this data, you can see this 13 is repeated, and this 28 is again repeated. So from the data only, you are able to get the idea that whether you have to use the repeated value formula or you have to use the non-repeated value formula. Okay, and hence we write the answer for this. So we go with the solution. Okay, so what we have here, let R be the Spearman's rank correlation coefficient between X and Y. Okay, so we have, now you know there are repeated values, so you have to write the formula for the repeated values. So what is the formula? So general form we can write as 1 minus 6 times summation di square plus 1 by 12 summation mi cube minus mi. Okay, and upon this n cube minus n remains as it is. This is equation 1. So we don't know how many mi's are there. So whatever the mi we can have, or how many times if it is repeated, we don't know. So we write the general formula like this. Okay. Now let us. So what we have here is di. Okay. So we got here di is equal to difference between the ranks of X and Y. N is equal to, N I'll write letter. So what is MI? MI is equal to ith rank repeated MI times. Okay, and N is equal to, as usual, number of observations. Okay, so what we got here? So this is going to be the number of observations. So what is the value of N here? Here, N is equal to how many observations we have? So you can see how many observations we got here. We have 6 observations. Okay, so value of N is equal to 6. And now consider the table. So what is the table that we'll have here? So we have X, we have Y, we have R1 rank of X, and then we have R2 rank of Y, and we have EI is equal to R1 minus R2, and then we want EI square. And so that's what we have here. We have the 6 observations. We are interested. We are interested in last. We are interested in last column. Okay, so see what are the observations we have. So it is going to be 6, 9, 13, 13. So we have here. It is going to be 6, 9, 13, 13, 11, 31. Okay. Now see what are the Y observations. 12, 19. Okay. So it is going to be 12, 19, 28, 28, 28, and 39. Okay. So that's what we have. Correct. Now see, if I rearrange this terms, so what is R1? R1 is rank of X. What is R2? R2 is rank of Y. Okay. So rearrange these terms. What will be having here? So you can see this is 31. Okay. So we have 31, then 13, then 13, then 11, 9, and 6. So we start ranking. These are repeated. So we'll be having 1, 2, 3, next 4, 5, and 6. Okay, but here what we have to consider average of this. So we'll be having 2 plus 3. How many observations? 2 observations. So it is going to be 2.5. And hence now see the ranks. So we'll be having here 1. This is 2.5. 2.5. Then we have, this is going to be 3 is already used. Okay, so we cannot use this rank once again. So next is going to be 4. Then this is going to be 5 and 6. Okay. What about this Y now? So you can have for Y, this is going to be 39. Then it is 28, 28, 28. then it is going to be 19 and 12. I'm writing this observation in descending order. Now see the rank. So it is going to be 1 for this 3, 2, 3, 4, then for this 5 and this 6. And now here what we have to do is average. So 2 plus 3 plus 4. How many observations? 3. So it is going to be 3. And hence we got the rank as what you're having. This is going to be 1. This is going to be 3, 3 and 3. Okay. And next we have this is going to be 5 and 6. Okay. So this is how we have to give the ranks. Okay. Once we are ready with the ranks, then we have to calculate the difference. Okay. So calculate the difference. This is going to be 0, 0. This is going to be 0.5. This is 0.5. This is going to be 3. And this is minus 2. So square, this is going to be 0, 0. 0.25, 0.25. Then this is 9 and this is 4. So you have 13.5. Now as we know the repeated ranks. So this rank is repeated 2 times and this rank is repeated 3 times. Okay. So you can see this is going to be 5. So we have 2 repeated ranks, M1 and M2. The first repeated rank is going to be, see, this is repeated 2 times. Okay. And then this rank is repeated, second rank is repeated 3 times. So M1 is equal to 2 because it is going to be 2 times repeated. M2 is equal to 3 because it is repeated 3 times. Okay. So that's what we have. So M1 is equal to 2 times repeated. M2 is equal to 3 times repeated. And once we have this di square M1 M2, so we are able to apply this formula and hence apply the formula here. So we can write from equation 1 we have R is equal to 1 minus 6 times summation di square. So di square we know. Okay. So I'll write here, I'll write a formula first. So summation di square plus 1 by 12. So it is going to be M1 cube minus M1 plus 1 by 12. And you'll be having M2 cube minus M1, M2. Okay. So this will be the formula and this whole term divided by n cube minus n. The value of summation di square is equal to 13.5. N is equal to 6. And we have already considered M1 is equal to 2 and M2 is equal to 3. Okay. So we use these values. Then we are able to get here as this is 6 cube minus 6. So what we get here is going to be 6 cube minus 6. So we get here 6 cube minus 6. So what is the answer you are getting now? No, after using 6, what is the answer you are getting? Okay. Okay. So, okay. So you used 6, that's good. Okay. Great. Yeah. So that's good. Okay. Then we got answer here. This is going to be 0.5428. Okay. So we got the answer here. This is going to be 0.5428. Okay. So that's great. So now, do you have any doubt? Okay, that's good. Okay, thank you.